Hi everyone, welcome. Thanks for joining us today. We're going to be talking about the United States Wind Turbine Database, which was just released last Thursday. This is Ben Hohen. I'm a research scientist at Berkeley Lab, and I'm going to introduce the rest of the presenters in a moment, but first just some quick housekeeping. Everyone on the line has been muted. You probably heard that as you were joining, but we'd like to hear from you, so please don't hesitate to submit questions via the chat window. You can do that at any time. We will be monitoring it throughout the webinar. So if you have technical issues, for instance, go ahead and submit them now. And any questions that come in, we will answer at the end of the presentation, just going through by order. All right, so let's get started. First thing I'd like to do is introduce the folks on the call, part of the U.S. Wind Turbine Database team. We also have on the call Hannah Hunt. She's from the American Wind Energy Association. She's the Deputy Director of Electricity Policy and Demand. And she headed up the connection that AWEA had with this effort, which was crucial because without the AWEA's data, we weren't able to build a robust data set. It's a combination of a variety of data sets you'll hear about, and AWEA's data was key. So she's been a great part of this project. Also on the line is Jay Diffendorfer. Jay Diffendorfer is a research ecologist at USGS, and he's sort of the spiritual leader, also the leader of the USGS effort. He was instrumental in developing a database that we'll talk about today that fed into and that this database built off of. Louisa and Chris, also from the USGS, were part of that project as well. So on to the real stars of the show today. Joe Rand is a researcher here with me at Berkeley Lab. He's going to be talking about the database management side of the work that he led. A crucial part, pulling all the disparate data sets together and cleaning them up, and he'll be talking about that part of the work in the first bit of the presentation. Next will be Louisa Kramer. She's a physical scientist at USGS. She's going to be talking about the visual verification aspect of the work. That's so crucial that each one of these turbines are looked at by a human to make sure they're in the right place and they're in fact in the ground. And then finally, we're going to turn it over to Chris Garrity. He's a geographic information specialist at USGS, and he was the developer of the website and the portal. So all the really cool features about the portal are really based on his creativity and hard work. So the first thing I'm going to do is give a little bit of project background and then turn it over to Joe, Louisa, and Chris to take it from there. So this project really started in 2014. The Wind Turbine Radar Interference Mitigation Working Group is a consortium of federal agencies that were put together to address wind turbine interference with radar. And to do so, they needed good data on wind turbine locations. And at the time, it became clear that although there were relatively good data sets together, there were some issues with those data sets, as we'll talk about in a moment. So this consortium was a consortium of the Department of Defense, the US DOE, FAA, and NOAA. The FAA is unique in that it also produces its own data sets. So these data sets you'll be hearing about a great deal today. The first data set is the Digital Obstacle File, or DOF. That represents every turbine that has been built in the U.S., though there are some holes where we have some turbines that are not represented in the DOF, and sometimes the DOF also has turbines that actually were not yet put in the ground. And the FAA data set, this one in particular, as well as the one I'll talk about in a moment, has information on location characteristics and also information on the height of the turbine, sometimes the maximum height, but doesn't have a lot of other pieces of information which are crucial and are part of the U.S. Wind Turbine Database. We'll talk about that more in a moment. The second database is the Obstruction Evaluation Database from FAA, the OEAAA. And this database represents not only the turbines that have been built, but the turbines that will be built in the future that are used to study whether they are a possible obstruction to the airspace. So this gives us a feel for turbines that will be built in the future. These two databases together form the seeds of a variety of databases, which I'll talk about in a moment. And as I said, these databases are lacking some important characteristics that are crucial for the wind turbine database we'll be talking about today, though serve as I said, the seed to those databases. And what are those databases? The first one on the left is the USGS database that was developed in 2013. I mentioned that Jay and Louisa and Chris worked on that development. And in 2014, it was still available, so this became one of the target databases that maybe the Interim group could use. As well, Berkeley Lab was at the time collecting their own data for their annual Wind Technologies Market Report. Though we weren't sharing it with the public, it was kept in-house, and it built off of the FAA database that we just mentioned and also added additional features from online sources and also from AWEA, who separately had their own database and still does. AWEA and Berkeley Lab at the time were working together. We were collecting kind of the same pieces of information from a lot of the same sources, the OEMs and the developers, and we were using the FAA database as the seed. So at that point we started to work together collaboratively to continue to collect those data so we weren't bugging the same people twice for the same information. But at that time, in 2014, both the AWEA database and the LBNL database were not being shared with the public. The USGS database was, but in 2014 it was the last update. So for the Interim group to do their work to analyze the possible interaction between turbines and radar, they used the USGS database. They used the AAA and DOF databases from FAA, and they also included data from other government.gov sources. But they recognized there was an issue there as the USGS database was no longer being updated, and the AAA and DOF databases only had certain information, and the .gov database was not able, the other sources of data from .gov sources were not able to be shared publicly. So there were a number of problems that they wanted to overcome. They were the fact that these databases were overlapping. As I mentioned, there was some limited information on turbine characteristics as they looked forward in time. There was limited geo-rectifying except for the past USGS database, meaning over time in the future there wouldn't be an opportunity for geo-rectifying these various databases. At the time there was no screening for decommissioned turbines, and no option for public release of the data because it had these .gov sources that could not be shared publicly. And at the time, it was not inclusive of repowered or retrofitted turbines, though those were just beginning to pop up in the database. And finally, there was limited long-term institutional support for maintaining a database such as this. So this is where the DOE steps back into the picture and had the vision to get USGS, Berkeley Lab, and AWEA together to collaborate on building a database that we'll be talking about today. So that's when, well actually the year after, in 2016, negotiations started on the Cooperative Research and Development Agreement, a CRADA, to do just that, build this U.S. wind turbine database. In 2017, the CRADA was signed by all parties, and we began work. The roles were designed as follows, as shown on the left. The Berkeley Lab would be in charge of overall project management and database management, as we'll hear Joe talk about today. The USGS was in charge of the visual verification effort that Louisa will be talking about, and also the website and portal design. And AWEA was responsible for sourcing key characteristics about the data set, which we'll be talking about today, as well as some initial location assessment that the database then built off of. So in earnest, we started building this data set in the first quarter of 2017. We started with just the Berkeley Lab, USGS, and both FAA data sets, combined them, and we moved to Q2 by taking the updated AAA data set. At that point, the Berkeley Lab and USGS data sets were no longer being updated by themselves. We all turned to this U.S. wind turbine database as our database. In Q3, we added all the AWEA turbines, which obviously duplicated many turbines in the database. which led us to Q4, where ultimately we took updates from AWEA as well from FAA, but started a very long process of manual duplicate removal so we could make sure that the turbines in the data sets were in fact unique. And that gets us to where we are today. I just will point out that the Interim group during this process served as an advisor, and we couldn't have done it without them. And so they were very helpful in giving us feedback along the process. So I guess with that, I will hand it over to Joe to talk about the database management side of the effort. Joe, take it away.
Great. Thanks for the introduction, Ben. So I'll dive right in. Ben already gave a good intro to these 5 different source data sets that we used to assemble the full US wind turbine database. But what I want to highlight on this slide, again, is just the release dates of each of these source data sets. So as you can see with the USGS legacy data set that we initiated the process with, that was last updated in March of 2014. The LBNL data set that was used in-house at Berkeley Lab was last updated through March 2017. And then, of course, we had the 2 data sets from the FAA, the digital obstacle file. The last one we used for the current release of the US wind turbine database was updated through January 2nd of 2018. The obstacle evaluation, or OE/AAA file, was updated through January 6th of this year. And then the 4th quarter AWEA 2017 database was released on January 26th of this year. So how did we merge all those 5 different sources of data together? We really used 2 different methods. Now, the first method of merging data together was by matching common unique identifiers that were shared across 2 or more different data sets. So an example of that is shown here on the left, where we have the FAA's Obstacle Repository System, or ORS number. And you can see that is shared across multiple tables, and that allows us to match unique turbine points and merge the data of those 2 tables together. The other method that we used to match data together we call Geospatial Matching, and that's based on the latitude and longitude coordinates of the turbine points, as well as the characteristics attributed to those points. So for Geospatial Matching, we used Stata software and used the GeoNear function within that software package, which determines the geodetic distance between 2 pairs of XY coordinates and then tells you that distance between those 2 points. In addition, as I said, we also used turbine attributes, so the characteristics of those points in order to match 2 points together. Now, we began using this legacy USGS data set from 2014. That data set contained 48,956 points. And the next step was to merge in the LBNL data set that was updated through March of 2017. That LBNL data set separately contained 43,827 turbines. We are able to match those 2 data sets together using that FAA Obstacle Repository System number that was common across both of these data sets. So this matching resulted in a large number of turbines that were matched across both of these data sets, but some turbines were also found, as you can see in this image, exclusively in the USGS data set, and also some turbines were found exclusively in the LBNL data set. The next step was to bring in FAA data. So again, we started with the FAA DOF, or Digital Obstacle File database. That file, as of January 2018, contained 49,191 turbines, and we were able to merge that into our master data set on the left, again using that FAA ORS number. Now, in some cases, if we were not able to successfully match the 2 tables together on that ORS number, again, we resorted to geospatial matching, and I'll talk about that in a little more detail now. So for geospatial matching, our process was really designed to capture only the highest confidence matches, where we are 100% positive that the 2 points we're merging together were in fact duplicates of each other. We knew that if we left any duplicate points in there that we didn't capture, the USGS visual verification process would subsequently capture those. So the idea with our geospatial matching was to reduce the burden on USGS through visual verification, but also capture some of these duplicates. Now, for merging in these FAA data, we use two different criteria for geospatial matching. Those are shown on the lower left. For the first type of geospatial matching, the 2 points had to be within 10 feet of each other, and the install year of that turbine point had to be within 1 year. For the second type, the 2 turbine points could be within 50 feet of each other, but those install years, or when the turbine was built and put in the ground, those 2 years had to be equal in order for us to determine that to be a match. So by using the matching on the ORS number and geospatial matching, we were able to bring in the FAA DOF file. And as you can see in this graphic, we had a large majority of the turbines matching across 2 or 3 of the data sets, but also, again, we had some turbines that were unique to each individual source data set. The next step was to bring in the other FAA data source, and that is the obstacle evaluation file, or the OEAAA. Again, as of January 2018, that separate data set had nearly 40,000 turbines, and those were matched to the master data set using the FAA's ASN number, or the Aeronautical Study Number. And once again, where that match on the unique ASN number failed, we were also able to apply the same geospatial matching criteria that I just described. So this master data set, as it was assembled, again, we end up with a large majority of the turbines being matched across some portion of those source data sets, as well as some turbines coming in that are unique to each source. The last step of managing the 5 databases and merging them together was to bring in the AWEA data. The AWEA data, the 4th quarter 2017 update that AWEA published in January of 2018, had 55,579 turbines. But those turbines and that database did not have a unique identifier that was shared among other data sets in our database. So we relied exclusively, entirely on geospatial matching to bring in the AWEA data. Now, the criteria for geospatial matching with the AWEA data were very similar to what we used to bring in the FAA data, but the criteria were slightly different. And again, I described them here on the lower left of this slide. So in this case, to bring in the AWEA data, the 2 turbines that were matching together had to be within 100 feet of each other when we ran this geonear function and determined the geodetic distance. As well, the criteria, or the attributes of those turbines, the hub height, rotor diameter, and the install year of those 2 turbine points had to be equal for type 1 geospatial matching. For type 2, the 2 turbine points had to be within 10 feet of each other, and the install year had to be within 1 year. So you can see our criteria for matching these points were fairly stringent. And we knew, again, any points that were not matched could be captured by USGS. So this resulted in what we call the Interim fully merged database. So this has data from all 5 sources, but we know that there are some duplicate turbines in this database. There may be decommissioned turbines that we have not captured yet. So that interim fully merged database was sent to USGS for visual verification. USGS, and we'll hear a lot more about this in the coming slides from the USGS team, but they identified duplicate points, also identified turbines that had been decommissioned but were not yet removed from our database, and as needed, also updated the XY coordinates. And I'll note here that the USGS team identified 5,897 turbines that were marked as decommissioned. So that database, after going to USGS, was sent back to LBNL, where we were able to remove those duplicate points and also remove the decommissioned turbines in order to assemble a final database. So that final database is shown here on this slide. After merging the 5 sources together, removing duplicates and decommissioned turbines, about 91% of the turbines in this final database were matched across at least 2 sources. with over 55% of the turbines matching across all 5 of the sources that we brought in. Ultimately, this final database has 57,636 unique wind turbines. And as you can see on the left, a large handful of those come in from USGS only, and currently about 30 turbines are exclusively coming in from the digital optical file from the FAA. Now there are 8 key wind turbine attributes that we're bringing in and keeping track of with this database. Those are shown in this table. And also the sources of where those data come from are shown in this table. So the key attributes, XY coordinates, online year, total height, as you can see, those come from all 5 of the source databases, whereas hub height, rotor diameter, the turbine's rated power capacity, the manufacturer, model, and the project name only come in from the LBNL, AWEA, and USGS datasets. Now those 8 key turbine attributes are very well populated across the US wind turbine database. So if you look across the full suite of turbines, over 87% of the turbines in this database have data populated for all 8 of these key attributes. And then each individual attribute, the percent of the database that is populated for each individual turbine, each individual attribute is shown in the middle of this table. So for those who want more information about the separate data sources, about the matching process, definitions of the variables, summary statistics of the data, we encourage you to go to the website and click on this link where you can download a detailed memo and codebook, which are updated quarterly and released with each quarterly update of the US wind turbine database. And what I show here are just images of that memo and the codebook which describe what are entailed in those data sets. So with that, I'll pass it back to Louisa to talk about the visual verification process.
Hi, everyone. I'm Louisa Kramer. I'm the U.S. Wind Turbine Database Visual and Geospatial Validation Lead. I want to explain the different types of verifications that I did that can help you understand what kind of process we had and about the massive effort it took to verify these turbine locations. For this webinar, I classified the verification process into 4 categories as shown on the slide. We have turbines that were already completed, ones that we had to move, ones that were added, ones that were removed, and for the removed ones, there's some subcategories that we've mentioned. Duplicates are extra points. There's also ones that weren't a turbine, small turbines, or turbines that were dismantled. And I'd also like to explain to you some different imagery types and the access to imagery I had. And also there's an attribute in the data about confidence location that I want to explain to you. So here's the easiest part. Joe talked about this. There was turbines already verified in the USGS data. So here's an example of that. They're good to go. They're on the turbine point. This was pretty easy. I did not review these. We left these as is. Then we have turbines. Sometimes they were new ones that came in recently since the USGS or the other data set had come out. And so somebody had located them in the wrong place, and we would have to move them so that they were on the turbine point. So in this example, we moved it 114 meters, and then I populated coordinates which were then sent to Joe, the keeper of the database. Here's a summary statistics of how we move them over the years. This actually includes the previous USGS wind turbine database that I verified, plus the more recent one that Joe gave me all put together. If you follow the orange line, basically over time, that is giving you the percent of all turbines in that year that were adjusted. So that basically gives you the number of turbines that we moved in percent. And then if you look at the blue bars, that's the mean distance that we move them per year. And you can see Oh, it's also, I want to explain that's weighted for the number, so that if there was a year where we moved one turbine a really far distance, we factored that in. So overall, you can see from this data that it's still, the data is getting better. We're moving less of them than we were, say, in 1999. And the distance that we're moving them is slightly getting better, but it has not completely gone away. So we will probably continue to check them visually until we start seeing these numbers go closer to 0. We also have a situation where we had to add turbines. Sometimes when I would zoom to a turbine like the one in red here, I noticed that the turbine points nearby don't have a point on them. So in this case, I just added them. Quite often in the next release, the DOF or one of those data sources that Joe talked about would show up with this. They just hadn't yet. But in cases like this, we pretty much have just added the coordinates. A lot of the attributes that Joe was talking about might be missing for those, and then maybe in the next quarter those technical specifications will come up and we'll be able to give you more information on them. We also have, as Joe explained, points, extra points. So we talked about that, and in this image on the right, you can see that there's more than one data point around the single wind turbine. In this case, that point is an extra. And just to give you an idea of how many extra points were removed, here's a summary by the most recent 4 quarters. So we removed, I did, by visual verification that I flagged to Joe, 11,400 turbines. Now, back to the picture on the right, in this case, one of the points happened to be on the turbine. So I would just let Joe know what the coordinates were and which one was correct and which one to remove. In other cases, neither of the turbines would be on the point, like in the image I showed you where we moved points, and I would have to move one of them to the exact base of the turbine, and I would let Joe know which coordinates those were. So he did a lot of that reconciling of the data, and I did a lot of the verification. We also had another category of turbines that happened in the data. They were other ones we removed that were, I call them mismarked, and we also removed residential. So data that was mismarked, like on the picture on the left, that's really just a tiny windmill on top of a water pump. There's a lot of these that ended up in our data, I think originally from the DOF, because people wanted to report windmills. We do not consider these turbines for our project, so I flagged those, and those have been removed from the data. Also on the right, the residential turbines are really difficult to track at this point. The data is not that great. If we find that we have better sources for this data, we will gladly add them back in, but we felt at this time that any turbines that we had technical information for, that the blades were less than 30 meters and it was less than 65 kilowatts, if we had that information, we removed them from the data for now. We also talked about turbines that were dismantled. You can see in this image, when you zoom to it, there's like an old concrete pad there. This turbine was marked as dismantled and removed, and we also have removed those when we've come across them in our database. This is probably most common in places like Texas and California, where turbines were built a long time ago, and they have probably been repowered in some cases or just removed. Now there is something here I did want to point out. Say the following day the turbine next to this one was removed. This data is a snapshot in time, so we may not have caught all of the removed turbines, and I don't really want anyone to use it as a current turbine status. We did the best we could, but we know at some point in time that every turbine in here was checked by a human. Okay, I want to go back to the imagery types that have been used in this data. This is also an attribute that you can look up in the data source based on imagery types. Bing map aerials were used mostly in the old 2014 data. We did not use it recently, but some of those points just carried over, so that's in there. It's just a base map that's used in the program ArcGIS. It's very hard to track what the imagery source was, and ArcGIS Bing maps changed. They always use the most recent image, so sometimes if you went back to that site, you wouldn't be able to know what image it was. But at the time, this was one of the better choices. Now it is not. Also, we use very infrequently Google Earth, which is available from Google. Most people are familiar with this data source. It was only used in a very limited cases. I have a couple examples of that later. Basically because it's hard for us to edit the data in Google Earth, the attributes and everything in the table. It's wonderful imagery, but we would have to go back and forth between screens, and it just was time consuming. So that was only limited. The third source here is NAPE. That's also one of those carried over from the 2014 USGS data. Eventually we're going to go back and look at all these and probably replace them with something more recent. NAPE is a flown ortho imagery. They flew planes and took pictures, and they're released only about every 2 years. So if a turbine was built in a gap year or just after the photograph was taken, we had to use another source. The interesting part about this data source that it goes back a long time ago. So if we're trying to look at old turbines, this is a wonderful reference in those cases. The fourth source here is pretty much obsolete, and it's another one of those from the 2014 data. So this is nearly phased out of the project, and there's only a few left in it. The best source that I found to use was from Digital Globe. Digital Globe EV web hosting imagery has a nifty tool that you can put inside ArcGIS, and it will stream all the imagery similar to Google Earth in ArcGIS. It has various levels of access, and I'll explain that in a slide, but to get the highest level access that I use, you had to have a .gov or .mil email address to sign up. And if you want more information about Digital Globe imagery, you can go to that website there. But that's the primary source. So when you look in the attributes, you will see that there is a source, and it will be one of these sources. I want to explain the location confidence. We talked a little bit about that at the beginning. The location confidence is rated from low to high. This is basically something that the reviewer, the verification viewer, would mark in his confidence, and if he saw a turbine or not in the image. As you can see, 0 is low, 3 is high, and 0, we didn't even get to look at that turbine. I'll show you some examples of this, but confidence location 1 is the turbine was not seen on the image. Confidence 2, it was in partial construction, and it only shows a pad and a base with turbine parts on the ground. And then the third one is turbine clearly seen. So here's an example within the same wind farm. On the left, the confidence is only 2. The turbine's not fully up. It's tough to see, but if you've looked at a million of these turbines, you will start to recognize it very quickly. The blades are on the ground on the left. And then the 2 on the right, it's full confidence. So that's how those were marked. Here's a better example of confidence location number 2. You can see that the parts are on the ground. It looks like it's in partial construction. Here is confidence location 1. There's no turbines. Nothing is seen. So we will have to revisit these turbines with updated imagery and make a determination if we want to keep these turbines in the data or not. But right now, when you're looking at this data, if the confidence is 1 or 0, it's not very confident. It's not confident at all that we found the turbine there. For this image, I made some notes up above. We accessed this imagery on 2/15/18, and the most recent Digital Globe image was way back in 2016. That's a pretty far spread. So that's the case where I was explaining I'd use one more source to try to find the imagery. So I checked Google Earth. So this Google Earth image was accessed on 4/17/18 just last week, And it also only has a 2016 image. Nothing more recent, no turbines. So that reaffirms that the problem with these turbines, in my guess, is the imagery just hasn't caught up with that location. Just before I did this webinar, I thought, oh, let's look at these again in Digital Globe in ArcGIS. So I just accessed this on 417. Oh, Digital Globe has now produced another image from March 2018. So finally, we have some 2018 imagery. So in the future release, next quarter, these turbines would change to confidence location 3. One other thing I want to point out here is my guess. I don't know for sure, but the Digital Globe imagery was checked that we just talked about on the same access date as the Google Earth of 4/17/18. I'm guessing that this image is part of the special EV web hosting imagery that .gov and .mil people with those email extensions can use because of cloud cover. I know that Google Earth won't show users something with a lot of cloud cover. So in this case, we lucked out that the cloud is sort of south of our turbines and I can see it, and I'll have access to that kind of image. But there is some turnaround time for in-house reviews, so turbines would not have been checked this recently. There's probably in March was probably the last time that we looked at some of the turbines, but some of the other turbines have not been looked at because they were already approved and seen in the 2014 data. The only ones that were revisited were turbines marked confidence location 1. We revisit those every time. Just to give you a understanding of what the data confidence location is comprised of, we have 0 turbines this round that have not been visually verified. We put that category in there in case too many are built or we don't have a fast enough turnaround for the next quarter. So we wanted to be able to release the whole data set and give you access to those, but we want you to know that anytime there's a confidence location 0 as we move forward, those data has not been visually verified. Confidence location 1 means we visited it, but it wasn't seen on the image, and there's only 1% of the data. Confidence location 2 was in partial construction. I showed you a couple of pictures of those. That was only 2% of the data. So 96% of the data, the turbine has been clearly seen in some image at some point in time. Here's one last slide for you. This shows all our points on a map of the United States. You can see most of them were fully confident. So the U.S. wind turbine database currently has 57,636 turbines in this April release, and all of them were looked at some point in time by a human. Thank you so much for your time. Chris Garrity's next. He has a great demo for you, and that's about it. That's all I have to say. Thank you.
Hey, thanks, Louisa. Can you hear me? I'm going to share my screen here.
Yep, we can hear you, Chris.
Great. And can you see the screen, Ben?
Yep, now we can.
Okay. You'll have to bear with me. I know how sometimes the screen capturing over the system can be a little choppy, and I'll be doing a lot of moving around. But as Ben mentioned earlier, my name is Chris Garrity. I was tasked with building the web mapping application and building the web space in general and kind of putting together some of the geospatial web service deliverables. I won't highlight everything in the database in the web space, but I will mention our data and web services available before I kind of show you the viewer. We have a variety of downloadable file formats because we know we have users with different needs. We have geospatial users, we have more database-driven users, we have neither. You know, we have folks that just want the web services, don't want to download the data. For our GIS users, we have some common formats like a shapefile format. We also have a GeoJSON format, an open format where anybody that has applications that can consume JSON can access the turbine database. Obviously, we have tabular versions like CSV and metadata files. We do have 2 geospatial web services. They are the same thing. One is a cache service, you know, so it's essentially a static snapshot of the database at some time. It moves quickly, but you're pretty limited in what you can do with it. You can access the underlying attribute information. But if you want to do things like filter or provide some data-driven styling, you'd probably be better off consuming the dynamic version of the service. Now, for the folks, really the majority of the people that are coming to this site, they're not GIS users, right? They're not database people. They're just citizens who want to access the database, view the database, and interact with the database. For them, we designed what we call the Turbine Database Viewer. So it allows users to access and interact with a database without the need for GIS software. All you need is a web browser. So I'm going to demo a few of the features of the Turbine Viewer and kind of show you the Turbine database if you haven't had a chance to look at it yet. So when I open the viewer, you'll notice I'm zoomed in on North America. You can see these green blobs. Those are essentially the coverage of the current Turbine database as a density heat map. Now, I don't have to look at it as a heat map. I can turn that into points if you'd like to see that. But in general, when you're looking for way zoomed out, it's kind of nice to see the overall coverage that the heat map provides. Nice thing about this surface is as I zoom in, you'll notice that the heat map morphs into the actual turbine points. So I kind of have two services in one. So the viewer itself has standard navigation tools. I can just click and pan. By default, I have zoom in, zoom out tools there on the left. This was built as a mobile application. If I have a touch device, all my multi-touch pinch gestures work in this environment. It is a 2D application, so I can implement kind of a pitch and bearing access, so I can look at the data in an oblique view, or so that can be useful at points. In most cases, people will just kind of pan or zoom to the area of interest. Otherwise, people will probably, up in the top right, you'll see we have a location, a geolocation bar. So I could enter something like an address or a zip code or a state. I'll enter Washington. By the way, it is a auto-populating tool. So especially when you're entering things like an address, you just have to start the address and it auto-populates with suggestions. So it kind of makes it easy. So here I'm zoomed into some turbines in Washington. Let's have a look at kind of what attributes we've exposed in the viewer. As I get closer, you can see the turbines in the satellite base underneath. And to access the information in any one of the turbines, I just have to mouse over if I have a desktop mouse device. Otherwise, if I had a touch device, I would simply tap the turbine. So the attributes that we included, and Joe mentioned a few of these, include the ID of the turbine, the project name, the year it went online, the rated capacity, hub height, rotor diameter, total height, the turbine manufacturer and model, and the attribute and location confidence that both Joe and Louisa were speaking about, and the lat long of the turbine itself. So again, kind of the more general attributes that we feel like most of the users are interested in. Right? We figure our power users will either download the database themselves and kind of access that other information in their own applications. This is a dynamic viewer in that if you notice as I pan and move around the right, things are happening here on my right sidebar. So, for example, I don't know if you can see it, but it says showing 165 turbines on screen with a total rated capacity of 337. As I move and pan around the map, that number is updated based on what's on my screen. So you have a dynamic count and a capacity rating based on whatever you're looking at. You'll also notice I have a project table here that is populated as I move. So in this case, I have 7 projects that are on screen. Each one of those projects is listed here. As I mouse over any one of those projects in the table, you'll see that it's highlighted in the interface. So the attributes that we expose on a project level are things like project name, the state that the project's in, the number of turbines within that project, the year that project went online, the total rated capacity of the project, and then we also have the average rated capacity for an individual turbine in the project. So if I wanted to zoom to the project, I could just click on it, and I'm zoomed into that individual project. If I have a user that knows their project name, So let's say, let me look at one of these. So if I was looking for the Bighorn project, for example, and I'll zoom all the way out here, we have a project utility up at the top that's, again, auto-populated with all the project names in the database. So if I start with Bighorn, it automatically is building an attribute list of the projects in the database. So again, another kind of quick way to access some of this stuff. I can sort the projects by year, things like capacity by name. I can filter that table, so I could build things dynamically. Like let's say I just wanted to look at the turbines that were in Washington. If I type in WA in my keyword filter, you'll notice that all the turbines out of Washington have dropped out of the interface, and things like turbine count, megawatt count, and project numbers change dynamically. Everything is made to work together relatively seamlessly, so it's very easy for people to make or get information relatively quickly. Okay, so you also notice that the turbines have colors. Let me go back out a little bit. You can see there's some blues and some oranges. That's because by default, we've applied a color ramp to the turbines, and by default, it's by rated capacity. That seems to be the most popular attribute that people are looking for. But if I wanted to dynamically change that based on something like height, you'll see that the colors change there subtly, or year, or if I didn't want to apply a color scheme at all, I could just turn that off, and you just have just every turbine with a single color. We also can filter the turbines dynamically. Right now we have a filter above this color ramp. We have filter to none, but let's say I wanted to filter by capacity, I could choose capacity, and then I could use my sliders to update this dynamically. So let's say I wanted to look for turbines between 1 megawatt and 2.2. You'll notice that a bunch of turbines have dropped out. And again, my project tables and my numbers are all in sync with my current filter. So things happen very quickly. I could do that by some of the major attributes we chose were height, year, and capacity. So if, for example, I wanted to search by year and I wanted to determine how, over time, maybe build an animation based on based on when the turbines were constructed. With my year capacity turn, I could start a plain timeline. You'll see that the timeline button is, the slider is moving, and you're seeing the growth of turbines in this area over time. These features don't have to be implemented locally. They can happen nationally. The viewer is made to be very quick, snappy, dynamic. So if I was looking at capacity nationally and I want to just look at turbines between 0 and 1.6 megawatts, you see things happen very quickly, even at a national level. I could even animate the entire construction of the database over time. You see they started construction here in the West. Things start to fill in Iowa over time, and then the rest of the country kind of fills in. So those are just some of the features available through the viewer. It's, like I said, a very dynamic viewer that's relatively snappy. There's a bunch of other little tools. I will mention that we have a pretty exhaustive help section where we kind of go into detail about all the features in there, and we give people examples of via animated graphics of common workflows. So even if you just want to kind of visually get an idea of how the turbine database works, you can do that through the help pages. With that, I think I'll pass it over back to you, Ben, if there's any other questions, or here you go, right there.
Great, thanks, Chris.
You got it.
And we might get back to that viewer in a moment here. There was a question that came in about that. So this is the time. We have 9 minutes or so until the top of the hour. We'll answer questions up in that time, and if more come in, we might squeeze a few more in after the top of the hour, but we'll give folks a chance to say goodbye if they need to. So this last page is really just contact information on all the members of the team. You can see kind of where they specialize. Please feel free to reach out to them. We also have a web address, an email address, US Wind Turbine Database at lbl.gov. that will go to the team, so one can email that. That's the same email address that's accessible through the web page, and so you can originate an email that way as well. There's the link to the database. It's interesting, you cannot at this point Google U.S. Wind Turbine Database and get us as the top hit. You can get us by putting in the abbreviation USWTDB. But hopefully we'll climb up, so it'll be a little easier for you to find it. But if you're interested in this map, we encourage you to bookmark it, and then you can get to it easily in the future. Please submit your questions if you got them, and we'll answer some questions as we go. We don't have too many here, so we should be able to get through with them. That shows how great the presentations were and how many questions you guys answered as you were presenting. So Chris, this first question is for you. Is there a way for the user to know how many projects are in a state or a certain area that you are zoomed into when you're looking at the viewer?
Sure. So
if you don't want to go back and share your screen, you can show that.
Sure. Okay. Let me do that. Let me know when you see that.
Just coming up. Almost. Now it's up.
Okay. So in that same example, if I was just interested in the projects in Washington, I could essentially zoom to Washington, type Washington in my projects window, and you'll see that right there that they're on demand. There's 32 projects in Washington with the total number of turbines in Washington and the total number of capacity, the total rated capacity of those turbines.
Great. Thank you.
You got it.
And the other questions are, well, there was a question about the presentation and will it be available. We need to have it review finished, but if the review works out fine, we will be posting this presentation as well as the recording from the webinar, but we need to complete a review process on that. And that is it, I think, right? There are no other questions. Let's just give it a minute here if anybody wants to chime in. Okay, first question coming in now is there a way to sort turbines by elevation? Chris, I'll let you answer that. I mean, I know the answer. But,
right. I mean, elevation is not in the database currently, right? So we're only filtering and sorting by what's available. But, I mean, yes. Okay.
All right.
I'll add a quick note. Oh, go ahead.
Go ahead. I have a feeling we're going to say the same thing, so go ahead.
Sure. So I wanted to note that in the database, if you download the data, like the CSV, for example, we include the FAA unique identifiers, such as that ORS number. So one could conceivably take the FAA ORS number, match it back to the FAA digital obstacle file, which does contain elevation data such as above ground level or above mean sea level for each of the turbines in the digital obstacle file. The problem is, of course, that wouldn't encompass every turbine that's included in the U.S. wind turbine database.
Yeah, that's great. Thank you. And just to be sure, we're by elevation, we mean the elevation of the ground under the turbine, not the elevation of the turbines themselves. There is a way to sort by total height, which Chris showed. So the next question is, what are the plans for the future plans for the project? Yeah, I don't think we made this clear enough because this is a question that's come up a few times. We will be updating this data set. The plan is to try to stick to relatively hard deadline of each quarter, so that might spill into the following quarter a little bit. We are on a cycle of doing that. So the goal would be to continually update this database each quarter until the future, until at this point funding runs out. But we do have support for continuing to do this for at least another few years. So I guess that answers the question there. Another great question, how can I add information that isn't complete? So this is something we've already been aware of as we've released this on Thursday, and there is that email address, uswtdb@lbl.gov. The best way to get in touch with us is through that email address, and if you have one single turbine that needs information updated, you can just add it to that email with the ID. It's very important you include the ID. But if there are lots of turbines that information is not complete, or you think there's issues there, we'll just work out another plan with you. We want to make it as easy as we can for folks that know what's on the ground, for sure, to let us know so that we can make those updates in future data sets. So hope that answers your question there. Okay, question about, there were a relatively large number of turbines in the USGS data set that weren't in any others. Can you provide any insight into why that is? So maybe Louisa, Jay, if you want to take a stab at that one.
Yeah, this is Jay Diffenberger. Thanks for the question. I think most of those stem, and Louisa can tell you this, but I think most of those stem from our early efforts to digitize all of the really small, old historic turbines in Southern California, or in California in general, that didn't have, they weren't in FAA because they were too small, they were old, so they weren't in existing databases. A lot of those turbines have very poor specs on them.
Exactly.
Yeah, I think that's why.
Yeah, this is Joe, and I might add just briefly that some of those are actually included in the AWEA database as well, but AWEA hasn't essentially put unique XY or latitude longitude coordinates for each of those turbines. They might have a really old project from the 1980s that they know has 200 turbines. They put them all in the same place. So we don't include that for that reason, because they don't have unique XY coordinates. Whereas, as Jay said, the USGS really went through all the effort to visually confirm where all of those turbines are.
Hi, and this is Hannah. I can confirm that's the case for those older vintage turbines in California. I can tell you from personal experience, there were days when we were talking right with the project managers, and they weren't able to confirm specific coordinates, so we did do that type of approximating for a larger number of turbines.
Yeah, and this has been, just adding one more point, we had already some contact with a company that is doing maintenance on some of the turbines in California, and they believe that they have more updated information than we have, and so we are going to be looking at those data and hopefully updating those turbines. So we encourage anyone that knows more about these turbines to get in touch with us, and maybe we can do updates as we go along. So the next question is, and so all right, let me stop for a moment here. It's top of the hour. I just want to thank all of the folks that joined us today for the webinar, and especially thank the presenters who put so much time into this project, and everybody as well on the team that have made this possible. It's been a real pleasure for me to work with this group, and it's exciting to see this now out there and already getting feedback. So if you have other things that you have to do, we understand if you have to drop off. We will stick around here for a little bit. We're getting a bunch of questions in we'd like to try to address. And so let's continue on maybe for 10 more minutes or so, and then we'll stop it there. So next question comes along. What about linking to the EIA data set? That's a great point. These data are now in the EIA Viewer, or will be soon. We were in contact with them as we were preparing this data set. They have currently the older legacy USGS data set in there, and they're going to be replacing that with this data set. So there'll be a way to look at them over top of each other, but we recognize it would be quite useful to have a code, a unique identifier within the data set, this data set, that could link to the EIA data set. That is one of the updates we do plan to do. It's not a one-to-one relationship, so it will require a little bit more effort, but we will work on that in the future. So hope you, and we'll let you know that that's the case. In fact, there is a mailing list on our website you're welcome to sign up for, so you can get updates like that. Question for, I guess, the group. Hannah, maybe this is something for you, and I can talk about the other source data. Will the consortium that are working with this data go back to the source data providers to correct potential discrepancies in the original data source? So that includes AWEA data and FAA data. the Berkeley Lab data and the USGS data are no longer. We are not collecting data on our own, and USGS is this is the USGS data set at this point. So the question would be for AWEA and FAA, will we go back and collect correct data there? Hannah, do you want to try that, and then I can talk about FAA?
Absolutely. I can say that our team here does make every effort to make corrections as they're needed. We welcome feedback like that, and I can tell you a bit more about our process. What we do is AWEA reaches out to all wind project developers and turbine manufacturers to confirm our data each quarter. That being said, changes can happen with the data over time. Turbines can get decommissioned, for example. They can go through partial repowerings, anything like that. So we are keeping the data updated on a rolling basis. We officially roll out the data to our membership, and then we send a subset of the data over to LB&L once a quarter. So there are circumstances where we will get an update, we incorporate it into our database on the back end, and we will make those updates, but it would take, the updates do happen every quarter, so that's when you would actually see it reflected on the front end.
Yeah, and about the FAA, I mean, we have not yet begun to work with them to provide some of the insights that have been gained through this process, especially visual verification and finding turbines that are in the ground but are not in their data set, or vice versa, data that are in their data set but are not apparently in the ground. We hope to have more relationship with them in the future. That is not something that we have currently done, but again, hope that happens in the future as we move on down the line with this data. Let's see. Are repowers captured separately? Joe, why don't I let you handle that one?
Yeah, this is a great question. So repowering, for those on the line who may not know, refers to potentially where old turbines are removed. They've run the course of their functional lifetime. Those old turbines are removed, but a new turbine is put right in its place. Another aspect of repowering that we might consider are what Hannah just alluded to as partial repowering. In these cases, we might have a wind turbine that the tower and the foundation are left in place, but it gets a whole new rotor, a generator, a nacelle possibly. So are we capturing these? The short answer is yes. In terms of the full repowers, the way that would look is we'd have the old turbine that's removed. That would be classified as decommissioned, taken out of the database, and then the new turbine that's put in its place would be included in the database. For partial repowering, we're also capturing those, mainly through the work that AWEA is doing, and then they're subsequently feeding us some of this data. We're able to capture where turbines have gotten, for example, a new, larger rotor. The total height of that turbine would change, the rotor diameter would change, the rated capacity might also change. So for example, those things we're able to capture and carry through in the database. Of course, there is a slight lag from when that construction occurs to when it actually gets into our database and updated, but that lag might be a quarter or at most 2 quarters before it would be updated in our data.
Great, Joe. And while you're at it, just it was a question specifically about the decommissioned turbines. You sort of mentioned it at a moment here, but why don't you talk specifically about what we do with those decommissioned turbines?
Yeah, that's a great question. So the decommissioned turbines, I guess I should clarify that we have a master database that we are keeping in-house at Lawrence Berkeley National Lab that holds all the decommissioned turbines in. So we have a record of all of those. But the database that you see that's published on the web viewer and that's downloadable to the public on this website we've shared today does not include those decommissioned turbines. So typically the process is that Louisa and the team at USGS might flag one as removed or decommissioned. We'll get that data back and we'll strip it out of this public database. I saw the question said, are these decommissioned turbines removed completely, or are they potentially just moved? The ones that we're flagging are typically removed completely. So we see kind of bare ground or just the foundation existing and no evidence of the turbine itself. So hopefully that answers that question.
Great. Let's see here. Another question about EIA data, and I just wanted to point out that EIA data is at the project level, so it's 1 point for the entire project, yet this data set is obviously at the turbine level. And so if we had EIA data points or IDs, we would add them to each turbine, so we again hope to do that in the future. There was another question early on about the possibility that some data are in our data set and not in EIA's data. That I wouldn't be surprised if that's the case. We have pretty current data now. Could be as little as a few months in delay only, but maybe as much as a quarter plus a few months. And we might have data in our data set that's before EIA, and plus there could be gaps when we found gaps in the FAA data too. So hopefully those will be cleared up over time, and we do think that we'll have a good working relationship with them in terms of updating their data. Their data collection happens because respondents are required to report it. It's a possibility, though, that some of that reporting isn't done. Let's see here. I guess this covers it all. We had a number of questions about repowering. I think we've answered those. And yeah, that's it. I think we've done it, and we're right where we need it to be. So any last words from the various folks on the team?
Thanks, everyone, for listening today.
Yeah, thank you.
Yeah, thank you.
Thanks, everyone.
All right. With that, we'll sign off. Have a great day.